Hey guys, here we are back again. Hopefully today I can finish this lesson. We'll see though. Okay, so today we're going to talk about evolution and the mechanism behind that Darwin came up with, which is natural selection. What the heck is natural selection? Well, natural selection is the idea that individuals that have a physical or behavioral trait that is better suited for their environment are more likely to survive. Now, this acts on a range of phenotypes. What I mean by phenotype is the physical characteristic of something, the way they look. So we're talking about, like, for example, my phenotype, if we're just kind of looking at me as an individual, I'm pasty white, I got brown hair, I got green eyes. Those are all phenotypes, okay? So the things that you can observe about something is a phenotype, okay? Now, obviously, keep in mind that evolution happens over millions of years. It doesn't happen just like that. Okay, I need you to keep that in mind. And an adaptation is inherited characteristics that increases an organism's chance of survival. It's inherited from mom and dad, that sort of thing. Okay, from generation to generation. It could be a behavior. It could be an appearance. It could be a number of different things that could help an organism to survive in their given environment. Okay. Now, adaptations become common in species. The more common it is, the more adapted the species is to survive in its environment. Okay, adaptations. So basically, these are adaptations. So this is the bare bones definition. I mean, they're adaptations that help organisms to survive, and they're inherited from mom and dad. Okay, I'm not sure if you can see that. Okay, and then they can be physical or behavioral. So I'm just going to kind of, they can be physical or behavioral. Sorry about my crappy handwriting. Physical, we're talking about speed, camouflage, claws, quills. Those are all examples of physical characteristics that could help you survive or be naturally selected to survive. Behavioral, we're talking about maybe an organism is solitary. It spends most of its time alone, such as polar bears, for example. They herd together, such as buffalo, to keep them somewhat defended, or like elephants too, or packs like wolves, that sort of thing. They're all behavioral characteristics that help an organism to survive. So again, just to kind of review over this real quick, natural selection is when certain variations survive, help to survive, reproduce, and pass their variations to the next generation. It takes many generations to develop, but it is what it is, and it's very important. And again, adaptations are very much luck of the draw. If a species does not adapt, it does not survive. Simple as that. So again, if we're talking about, say, what's the best example I can give? The best example I can give, and it's a very harsh example, I'm not sure if it's really going to work out, but whatever. If we're talking about out in Africa, the cheetah, for example, if you look at it compared to, say, a polar bear, their pelts are completely different, how much fur they have, how much body mass they have. Let's just say that out in Africa, all of a sudden it gets into like a tundra situation where it's like snowing all the time. The climate completely and utterly changes. If the cheetah does not adapt and change in a favorable manner, then it's not going to survive, that sort of thing. Okay, so again, that's a very simplistic way of looking at it, but I think it drives the whole idea that what natural selection is and how it works. Okay, it's a very long process, and only favorable traits will survive, depending on the given situation. Okay, that sort of thing. So now that's natural selection. The one that you guys are probably most familiar with is okay, so in natural selection, the organisms or trait that survives or that is beneficial is chosen by Mother Nature. Not me, not you, them. Artificial selection, traits are chosen to be passed on by you and me. So the best example that I always give are dogs. Dogs we have genetically and artificially selected for generations and generations, all the way back from the wolf into what we have today. I mean, today we got dogs like my dog, who is a Dalmatian with spots, to these little tiny Chihuahuas that are very tiny. And we got huge variation there, but those are all traits that we selected to be passed on. If you ever get a chance and you want to get a good idea, you should look at what corn looked like before we got our hands on it. It looks completely different to what we see nowadays. Now, here's the idea. We said that this is what Darwin came up with, that natural selection are adaptations that are passed on or inherited. He came up with that idea. The only problem with this idea was that during Darwin's time, there was no mechanism to explain natural selection. He couldn't figure out how they were inherited. How did that work? He couldn't explain that idea. Okay, so given a couple hundred years, so basically, nobody believed him for the most part. But fast forward to about 20 centuries later, a guy by the name of Mendel basically proved his work, essentially, with his work on genes, which we're not going to get into right now. But so he couldn't prove or figure out how the inherited stuff worked. Okay. Now we're going to talk about some ideas of evolution and how it works. So now I want you guys to, you know what? I'll do it right now. Why not? I got my iPad right here, huh? Okay. Now, what I'm going to be talking about today is common descent. This idea of common descent, what it means is that Darwin proposed this idea that individuals of a species reproduce, they change over time. These changes could lead to a divergence from a common form. So basically, species that are similar diverge from a common ancestor, essentially. Okay, and I want to show you guys a picture of what I'm talking about here. Okay, so for example, sorry, this is taking forever. I apologize. All right, take a look at this. What do you notice about this picture right here? Does it look familiar? Ta-da! And if you look at whales, inside their huge flippers, they have something that looks like this. Why is that? Well, it comes back to this idea of common descent. That maybe we have a common ancestor. That eventually what happened is we evolved or branched off into completely new species, but we kept things in common between us. Okay, that's what common descent means. We had a common ancestor, which led to common traits. Okay, so that's what common descent is. It kind of backs up the whole idea of evolution and that things changed. Now, obviously, it's descent with modification. Takes place over a long period. So we're talking about body structures, habitats, behaviors. Those are all things that we could modify or change about ourselves or about an individual. Now, obviously, we look very different from our ancestors prior because of, well, a common ancestor, and then also it just branches out, kind of like the roots of a tree. Okay, divergence. I'm not going to talk about that, I don't think. Speciation is the formation of a new species. Okay, divergence is the dividing force between speciations. Species can form species or specimens. All dogs are the same species. Okay. Due to artificial selection, they are very different. So basically, they have a common ancestor of some type. So that's where that common descent thing comes into play, thus resulting in subspecies. Subspecies are members of the same species that differ genetically because of a different living condition. So we're talking about, obviously, the common ancestor of the dog is the wolf. Now, when we talk about there are different species because genetically, as we take in them, they have gotten to the point to where their behavior has become dependent upon you and me. So basically, they became a new species over millions and millions of years. I'm just trying to get you guys the main idea because I only got 15 minutes here, and then I'm trying to go through this quick. I'm sorry. Just trying to give you guys the main ideas here. So again, that idea of how the hand, and I talked about the idea of like a cat's foot, or arm, whale, bat. Those are all examples of homologous body structures. So basically common descent, we have common traits or homologous body structures. Homologous body structures, again, homologous just means the same. Body structures, structures that are in common. All four-limbed animals with backbones descended from or modified from a common ancestor. And again, this is all triggered or fueled by the idea of natural selection and adaptations to survive. Adaptations that are beneficial, okay? So again, it comes to this idea of vestigial structures too. Vestigial structure is basically a structure in your body that at one point had a use but doesn't anymore. A lot of organisms have them. For example, our appendix in men, legs on skinks, pelvic bones on whales. Those are all examples of vestigial structures that no longer play a role. We evolved past that, needing them. Another idea that supports evolution is this idea of embryos. If you look at embryos for human, pretty much human, cat, dog, sharks, even fish, you're going to notice that as an embryo, we all look pretty similar. Okay, that sort of thing. I wish I might show you a picture here. Let me see. Where's my iPad? Sorry about that. Ew. This one's sick. I love it. I'm going to show you this one. Okay. So, like, to give you guys an example here. Here we go. So, as you can see, it's going up and down here. So, off to the right here, you have humans right here. So, as you can see, as an embryo up on the top, you really can't tell the difference between organisms on the very top row. In the middle even, you can see some differentiation there in the last two, but then it becomes very unclear as to who is who. So again, this kind of fuels the idea of that we all had a common ancestor at one point that we just kind of deviated off of. Okay. Again, let me review real quick because I think I'm pretty much wrapping it up here. Evolution is this idea that our traits, our phenotypes, our behaviors, stuff like that, can all be passed on into from our DNA from our mom and dad. They can be physical or behavior, and again, we're talking about just our phenotypes that can be passed on. That's the idea of natural selection. That's basically what Darwin came up with. And again, from that video, that same guy, the other guy, he came up with that idea as well. And then we came up with this idea. He came up with this idea of common descent, that we all had a common ancestor at one point. Then all of a sudden, we just branched out. We all had a common ancestor, and then we just kind of branched out from there due to our environments and what else have you. So again, we probably had, I don't know, and then you had an ancestor there, then you had a bat, then you had humans, I don't know, and then you had whales. Okay, but again, there was that one common ancestor that had that idea of those homologous body structures that we all inherited from that same individual. Okay. Anyways, that pretty much wraps up the chapter for now. So again, hopefully you guys took something away from this. Until next time.